All right, folks, welcome to another video lesson. This is for section 1.4, rewriting equations and formulas. And the objective today is going to be to do just that, rewrite equations with one or more variable. So again, you should have the title, you should have the objective written down, and you should have all these problems that we do here, including the ones I asked you folks to do on your own. So let's start off with a form that you should be familiar with. This is the general form for the equation of a line. 9x plus 2y equals 14. So I have my x and y on one side together, and I have a constant on the other side. I want to get y by itself. So here's the idea, and really this is kind of the idea throughout. That's what I want by itself. I want that variable y by itself. Everything else get on the other side. So this 9x term, I don't want it there. I need to get rid of it. Well, right now it's being added to the left side, so I'm going to subtract it. And I get 2y equals, and now this is just preference. I like to write my x first and then my constant. That way I'll end up in y equals mx plus b, my slope-intercept form. So I tend to write my x's first. Okay, so what's next? Well, I have this, where'd it go? I have this multiplying by 2 that's happening here, right? I don't want that multiplying by 2 there anymore. I want to divide by that 2. So that's exactly what I'm going to do. I'm going to divide both sides by 2. And I'm going to get y equals, and I'm going to split this up into two fractions. I'm going to write this as 9x, or 9 halves x, if you will, and then plus 14 over 2 would be 7. And now notice how y is by itself. This is isolated, right? That's by itself. So that's where I want it. I'm done. I really just unwrapped. You've done this numerous times when you've solved an equation. We just have a variable in there as well, and we have a variable in the answer. Okay, so let's apply this concept to a common formula, at least one common formula. We'll do this actually a couple times here. So the formula for the perimeter of a rectangle is the perimeter P equals twice the width plus twice the length. And that should be something that you guys should be familiar with. But again, I am giving it to you right there. So we're going to solve for W, right? I want to get, here's my W. I want to get that all by itself. So what's the first thing that we need to get rid of? Well, it's this 2L, right? I want to get rid of this adding of 2L. So I'm going to subtract 2L from both sides. When I do that, okay, let's look at the left side here. P minus 2L, those aren't like terms. So I really can't subtract them per se. I just need to write it as P minus 2L, just like that. And then this is going to equal 2W. So again, I want to get one W by itself. So I want to unwrap this multiplying by 2 right here, right? I want to get rid of that. So what can we do to get rid of or unwrap the multiplying by 2? Well, I'm going to divide by 2. Okay, so I divide both sides by 2, and I get P minus 2L all over 2 equals W. And that's certainly fine to leave it just like that. Some of you folks might recognize that we could split this up into two fractions and get P over 2 minus, well, this would just be L equals W. That's fine too, absolutely. But there's nothing wrong with leaving that just the way it is, particularly when we have multiple variables. But again, nothing wrong with the second one either. So either one's fine by me. Okay, hold on to this or keep this handy because we're going to use this two problems from now. We're going to come back to this idea. But first, you guys are going to get a little bit of practice trying this one on your own. So here's an equation for the area of, I believe this is a trapezoid. And I'm going to have you folks solve for B1, B sub 1. So take a moment and solve this out, and I'm going to put the solution up here. So the solution I get is B sub 1 is going to be 2A over H, and then minus B sub 2. So did you clear the fraction in this one? Did you multiply both sides by 2 at first? And then you should have divided by H, and then you should have subtracted B sub 2. So hopefully you saw that. Again, if you're not quite comfortable with these yet, we will get some practice tomorrow in class, just like we did the other day. Okay, so let's apply this now. Let's put some of this rearranging actually into some practice here and see why this is useful. So, and we're not going to actually solve a problem here. We're just going to write an expression, and then we'll be done with it. We'll do some solving at a later date. So we have 100 feet of fencing with which to enclose a rectangular garden. So we're going to express the garden's area in terms of the length only. So let's look at the information that I'm giving you here. We have 100 feet of fencing. Well, that's the perimeter. So the perimeter, which we know is twice the width plus twice the length, that's 100, right? Okay. But that's not really the question. The question is asking to write the area in terms of the length, which is why I have this area equation written over here. So if you look at this right now, we have the area in terms of not just the length, but the length and the width. So the idea is we want to solve for W and then substitute. So that's what I'm going to be working on here. Solve for W, then substitute. Well, luckily, we've already solved for W, haven't we? I'm going to go back 2 slides here. And where is it down there? Here it is right here, right? W equals P minus 2 over L over 2. So I'm just going to write that here. W equals P minus 2L over 2. And my board's doing funny things right now. Okay. All right. I'm getting there. Okay. So, well, I can substitute that right in directly right now, but I'm going to make this other substitution of, I know the perimeter equals 100. So I'm going to clean this up a bit before I go ahead and do all the substitution. So I get W equals, well, it's 100 minus 2L over 2. And now it certainly makes sense to actually do this division. I have 100 over 2. Well, that's 50. And I have minus 2L over 2. Well, that's minus 1L. So I can simplify this and say that my width equals 50 minus my length. And that's a minus sign, believe it or not. Okay, so the reason why I want to be able to rearrange that is now I can put this into my area equation, right? I'm going to take this expression for W and throw that all the way up in here. Okay, so I've got all these arrows pointing every which way. Let's get some of this out of the way here. Okay, so I'm going to rewrite this area equals length times width equation. And I'm literally just copying this, but in place of W, I'm going to put this entire other expression of 50 minus L. And you can distribute that L if you like. I'm actually going to do that. But more importantly, what I'm going to do here is my notation on the left side. So now that I have this entirely in terms of L, I'm going to write this using function notation, which is A of L. That's the important part. It's kind of like f of x or g of x, where we have just one input x in that case, right? Well, I have my one input L, I'm going to write it in function notation. And I'm going to go ahead and distribute just for some practice here. I get 50L minus L squared. So be careful with that distributing. Make sure you do that properly. But that's our expression for the area in terms of just the length only. Okay, so did we do the things I said we were going to do today? Did we rewrite some equations using using more than one variable? Well, yeah, that's precisely what we did. We did some real-life applications, and hopefully you saw some use out of this too with that last problem. And again, we'll see that more as we get through the class as well. All right, so take care and have a good day.